Hello all, this video is a step-by-step tutorial on using GSM module with Arduino. You can use SIM800 or SIM900 module as the AT commands are same for both the modules. On-board GSM module is a power regulator and a MAX 232 IC is provided for RS232 capability. The TTL pins are extended so that you can easily connect it with Arduino. Only 3 wires are required for connection between Arduino and the GSM module. A stub antenna is provided and at the back side a SIM slot is there. You can insert a valid SIM into this slot. You cannot use 4G SIM as the GSM module is 2G or 3G enabled. If your SIM is micro or micro type, you can use a converter like this and insert the SIM into the slot properly and lock it. An USB to TTL board can be used to connect with the PC. This creates a VCP, that is virtual COM port, so that you can use a serial monitor and test the AT commands easily. Only 3 wires are required for connection: ground, TX and RX. This type of USB to TTL board is made on CP2102 IC. Alternatively, you can connect RS232 to USB cable. Inside this cable, CS340 IC is used. This also creates a VCP, virtual COM port. The RS232 connector can be plugged onto the GSM to the 9-pin D connector, and the other end can be connected to the PC. In this demo, we will be testing AT commands using the RS232 cable, and then we test with Arduino by making call and sending SMS. And finally, we use a MQ2 smoke sensor for a mini project, smoke alarm. A separate power adapter is required for powering up this GSM module. Do not power it up from Arduino. You need a separate adapter like 12 volt 1 amps or 9 volt 1 amps. Power up the GSM module and look out for the network LED. It blinks fast initially, and once the network is received, it will slow down. This indicates that you have received the network and ready for testing. The first test is to call the SIM number on GSM and ensure that you get a ring back. After connecting the RS232 cable to the PC, open the device manager and note down the COM port. For this, you have to install the drivers. Here it is a CS340 driver, and note down the COM port allotted inside the device manager. We will be using a terminal software for testing AT commands. Here I am using PuTTY terminal software. Open the PuTTY terminal software and feed in the COM port that is allotted inside the device manager. And under settings, you can terminal setting, you can select local echo as force off, and then put a tick mark against carriage written after line field, and then click finish to open the terminal. Now if you type in AT, the GSM will respond with an OK. Now you can test other AT commands. AT plus C REG question mark will inform that whether the SIM is registered or not. AT plus CSQ will return the signal quality of the GSM. AT plus IPR question mark will return the baud rate of the module. By default, it is 0, which means auto baud setting. If you want, you can change to 9600 by AT plus IPR equal to 9600. For making a call, you use ATD command. ATD followed by the phone number and then a semicolon. A semicolon is a must. To hang a call, you give command ATH, and to attend a call, you give ATA command. Now make a call to the SIM number on GSM. You will get ring display on the monitor. To know the caller number, you enable the caller ID by AT plus clip equal to 1. This enables caller ID and the incoming call number will be displayed. To send SMS, first you have to enable the text mode. For this, use AT plus CMGF equal to 1. This enables text mode of the GSM. Now use the command AT plus CMGS and provide the phone number to which SMS to be sent. This phone number is to be within double quotes. After this, you get a greater than symbol. After this greater than symbol, you type in the message to be sent. And then finally press Ctrl Z to send the message. Ctrl Z is to send the message. To read all the incoming messages, use the command AT plus CMGL equal to all in double quotes. This displays all the incoming messages, all the messages in the storage area. To read a particular message, you can use the index number, and to delete all the messages, use the command AT plus CMGD equal to 1,4. This deletes all the messages in the storage area. Now let us test the AT commands using Arduino Uno. The connections between Arduino Uno and GSM is simple. Only 3 wires are required. Ground, TX and RX. Ground goes to ground, TX goes to RX and RX goes to TX. A separate power adapter is required for GSM. Connect the Arduino Uno to PC and then open the device manager. Inside the device manager, you note down the COM port that is allotted to the Arduino Uno. Now open the Arduino IDE. Select the board as Arduino Uno and then select the COM port as the port allotted inside the device manager. Now let us see the simple code for making a call. We use a char variable, array variable to store the phone number to be called. And inside void setup, we start the serial.begin using 9600 baud. And after a delay, we send the command AT using serial.print. After this, a delay is required. And then the next command is ATD. We use the serial.print and the serial.print the phone number. And finally, serial.print line a semicolon. Note the usage of serial.print line in the third command, which introduces a carriage return. For CR, we use print line, and to print on the same line, we use serial.print. So ATD, a phone number and a semicolon is finally sent, and then a delay of 10 seconds is a must. If you don't get a call, you increase this delay to 12 or 15 seconds. And finally, we send the ATH command with the print line with carriage return. Now upload the code. Remember to remove the RX and TX connections of Arduino before uploading the code. Connect back the RX TX wires and then open the serial monitor to notice the AT commands landing. First AT command is sent, and finally ATD phone number and a semicolon. Now the call is made. After a delay, ATH is sent to hang the call. Now let us see the code to send SMS. We use two integer variables. One is times to send and another one is count. And then the third variable is to store the phone number, that is the char array variable. And inside void setup, we begin the serial communication with baud rate 9600, serial.begin 9600, and after a delay, we send the command AT plus CMGF equal to 1. This enables the text mode. We use serial.print line so that carriage return is also introduced. And then starts the loop. Inside the loop, we test for the condition count is less than times to send. Initially the count is 0 and times to send is 1, so that only once is SMS is sent. As we are using inside the loop, we should be careful. SMS is sent only once. And then we use the serial.print command to send AT plus CMGS equal to starting of the double quote, and serial.print phone number and serial.print line the end of the double quote. Notice the use of backslash. a prefix to the double quote. This is how we send the escape character. Always use a backslash in front of the character, so that the special character is sent. A delay of 1 second is introduced. This delay is a must, so that it waits for the greater than symbol, and then the text message to send is sent using serial.print, and finally a hex 1A is sent to introduce control Z. Notice the use of serial.write to send the hex character 0x1A. Control Z is sent as a hex character 1A. If you want, you can introduce carriage return using 0D and the line feed using 0A. And finally, you increment the counter. This is very important, otherwise SMS will be sent repeatedly. Now compile the sketch and then upload it. Before uploading, remember to remove the RX and TX wires of Arduino, and then click upload. Once the code is uploaded, connect back the RX TX wires and then open the serial monitor. Now you can see the AT commands landing. First AT plus CMGF enables the text mode, and then AT plus CMGS the phone number within quotes, and it waits for the character symbol, and then the text message is sent. Now let us see the mini project using MQ2 smoke sensor. This MQ2 smoke sensor has VCC and ground pins. VCC can be used from the Arduino itself, 5 volt, and it has got two outputs, D0 digital output and A0 analog output. We will be using the analog output A0. The IC you see here is the digital output comparator. Connect the 5 volt to 5 volt of Arduino and ground to ground. You can see the power LED lighting up on the MQ2 smoke sensor. Allow some seconds to heat up so that the sensor is ready. The potentiometer provided is to adjust the digital output. If you adjust this potentiometer, you can see the green LED glowing while the output is high, digital output. But we are not using the digital output, only the analog output is used. So connect the A0 of gas sensor to A0 of Arduino. The other connections are same, ground to ground, TX to RX and RX to TX. Now let us see the code for this smoke alarm. First we define the sensor pin as A0 using the define statement, and then we use the integer variables times 2 second and count, and a phone number array variable to store the phone number to send SMS and call. Inside the void setup, we use the serial.begin to start the serial monitor at baud rate 9600, and then we enable the text mode using AT plus CMGF equal to 1. We need not use the spin mode to declare as analog input, as it is not required. And inside the loop, we use a data variable, integer variable, to store the analog read value of sensor pin. The sensor pin value is read by analog read and then stored inside the data variable. When the smoke is detected, the analog value increases, and when it reaches 200, we have set the threshold as 200, it enters the loop, while loop. That is when count is less than times to send. First the ATD and phone number is sent. So a call is made, and after a delay we send the SMS. We send SMS using AT plus CMGS and the phone number. Notice the delay between the dial ATD and then the SMS commands. The delay is a must. After that, we use the serial.print to send the message, the caution message, and hex code 1A to send the control Z. And then we increment the counter. Now upload the code. Do not forget to remove the TX-RX connections before uploading. Connect back the TX-RX pins and then open the serial monitor. Now you can see the analog read value, and when smoke is exposed to the MQ2 sensor, the analog value increases. Once the analog value reaches 200, the dial ATD command is sent so that the call is made, and finally the SMS is sent, caution SMS is sent. You can see the SMS received at the phone number, and also before that call is made. Thank you for watching.